Another type of reaction is a single replacement reaction. In this reaction, one element replaces another element in a compound to form a different compound and element as products. So let's look at this general reaction. So here A is replacing B from BC and B is out. So once A is replacing B, so now it is combining with C to form AC plus B. Let's look at the example. For example, sodium metal reacts with hydrochloric acid to produce, means arrow, sodium chloride. Sodium chloride is NaCl and hydrogen gas H2. Remember in the last video I gave you a list of 7 elements that exist in the diatomic form. So if you look in this reaction, what's happening, that sodium is kicking out hydrogen from HCl and taking its place, and hydrogen is released as hydrogen gas. Now once we are done writing the reaction, the next thing you do is to balance them. So here one sodium, one chlorine, one hydrogen, but there are 2 hydrogens on the product side. So that means I have to put 2 here on the front to make it 2, but then that will make chlorine as 2 as well. So then I have to go back to balance this chlorine on the product side to make this 2. And how will I make this 2? By adding 2 here. So this is 2 chlorine. Then this changed the number of sodium. So now I have to go back and balance sodium again. So if you look at all the balancing, 2 sodium, 2 chlorine, 2 hydrogen, 2 hydrogen atoms. The formula for NaCl, when I wrote down NaCl, it was not because there is 1 sodium here and 1 chlorine here. No. When sodium is replacing hydrogen to combine with chlorine, then you have to go back to your ionic compound chapter and think, when sodium is combining with chlorine, then what should be the formula? Sodium is in the first A group, so it will have 1 plus charge. Chlorine 7th A group, 1 negative charge. 1 plus cancels out with 1 negative and it makes NaCl. Let's take another example. Okay, before we start another example, let's say if you're going to put sodium in hydrochloric acid, what are you going to observe that is going to tell you that the reaction has taken place? So look here, in this reaction the gas is evolved, and so you will see the bubbles coming out that will show you that the reaction has taken place. Anytime a gas is formed, we put this upward arrow. This upward arrow shows that it's a gas, or you can just write down G. This is AQ. Let's look at another example. Silver metal reacts with copper nitrate solution. And here I did not give you the products. But if I tell you, okay, this is a single replacement reaction. So silver metal, Ag, reacts with copper 2 nitrate. Copper 2 means Cu with 2 plus. Here NO3 with 1 negative. So my formula will be, swap the numbers, so it will become CuNO3 twice. Now if this is a single replacement reaction, then what does it mean? That silver should replace copper from copper nitrate. But it's not that every time you mix two things, then the reaction is always taking place. For single replacement reaction, this is the reactivity series that you need to know. You do not have to memorize it. If you will need it in the test, it will be provided. So this is the reactivity series: lithium, potassium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver. And the upward arrow, this shows the increasing activity. This is also known as activity series. From this activity series, this activity series tells you about the reactivity of the metals. For example, if you look at lithium and potassium, lithium is above potassium. That means lithium is more reactive than potassium. So here silver is replacing copper, and silver can replace copper only if silver is more reactive than copper. So let's go look in the activity series. Here is silver and here is copper. Copper is more reactive than silver. Silver is less reactive, and if silver is less reactive, then it cannot replace copper from copper nitrate. So that means if you are going to mix these two, then no reaction will take place. And if no reaction is taking place, means you're not writing any products. Let's take another example. Zinc, solid, zinc metal reacting with copper 2 chloride. So first thing, is this reaction going to take place? Then we go back and look at the activity series. Zinc is here and copper is here. Since zinc is above copper, that means that yes, zinc is going to replace copper. And when zinc is replacing copper, then copper is kicked out. So we're going to put it here. Copper is a metal, solid. And now zinc is combining with chlorine. When zinc is combining with chlorine, then what is the formula for zinc chloride? Zinc has 2+ charge. Chlorine has 1 negative charge. You swap the numbers and that is ZnCl2. Again class, ZnCl2 formula is not because there is 1 zinc and 2 chlorine here. No, you have to do this ionic compound nomenclature. You have to go over that to write down the formula. So now I have equation, and once I have equation, I always balance it. Zinc, one zinc atom here, one here, 2 chlorine, 1 copper. So equation is balanced. And when you will put zinc in copper chloride, how will you know that the reaction has taken place? What will you observe? Copper chloride solution is blue in color, and since zinc is replaced and zinc chloride is colorless. So this blue color will start getting colorless. Not only that, it is making copper metal. Copper is brown in color, so you will see some solid appearing, brown in color solid appearing in the solution. That will show you that the reaction is taken place. Now this reaction is also known as oxidation reduction reaction. What is an oxidation reduction reaction? In this reaction, or this involves oxidation and reduction, metals oxidation definition is loss of electrons. Reduction is gain of electrons. So this is the definition of metals, and we discussed it before. Metals lose electrons, and when they lose electrons, they become positively charged. So here, look at the reactants. You always look at the reactants, you don't look at the products. Look at this metal. This will lose the electrons. How many electrons it will lose? 2 electrons. And so it's going to have 2 positive charge. That means we're going to say that the zinc is getting oxidized. Non-metals gain electrons and get reduced. Now here, zinc is above copper. Here we are talking about zinc and copper. Since zinc is above copper, zinc will get oxidized and copper will get reduced. And what is reduced? Reduced is the gain of electrons. So this here is Cu is present as Cu2 plus. It is gaining 2 electrons to make copper. 2 plus 2 negative gives Cu. So this reaction, reduction, so this is called reduction. So this reaction is also known as oxidation reduction reaction. Zinc is getting oxidized, copper is getting reduced. There are some other definitions for oxidation and reduction too. I don't want them to explain it here under single replacement because those are not single replacement reaction, but I will explain you at the very end. The next type of reactions, or the last type of the reactions, are double replacement reactions. So if you look at here what is happening, A is taking C's place and C is going on A's place. So if I'm replacing A with C, that means I'm making CB. If I'm replacing C with A, then I'm making AD. So that is called double replacement. So let's take the example. Potassium carbonate solution, and you need to know these formulas. These all are coming from ionic compound nomenclature. Solution means AQ. Barium chloride, barium Ba2 plus, chloride Cl negative. Swap the numbers. They use the word solution, put aqueous. To produce barium, okay, this is wrong. This should be barium carbonate. Barium carbonate, Ba has 2 plus, carbonate has 2 negative, so BaCO3 plus precipitate means solid plus KCl. Double replacement reactions take place only if at least one of your products is solid, liquid or gas. What is left then? Aqueous. If you have everything written as aqueous, that means there is no reaction taking place. In this case, a solid is forming, so it's going to precipitate out. And once you are done writing the equation, then what you have to do is you have to balance it. So there are 2K, so you put 2 here, 2Cl, 2Cl, 1 barium, 1 barium, 1 CO3, 1 CO3. So the equation is balanced. Let's take another example. Sodium bicarbonate, it is NaHCO3. Sodium bicarbonate solution, when you put this in HCl or when you add HCl into the sodium bicarbonate reaction, then sodium is going chlorine place, hydrogen is going here. Sodium is combining with chlorine. Sodium is Na plus, chlorine is Cl negative, makes NaCl solution. And this H is H plus and SCO3 is negative, and H plus with SCO3 negative makes carbonic acid H2CO3. This is also aqueous. Now we said if everything is aqueous means no reaction, but then how come the reaction is taking place? Because this carbonic acid, when it is formed, it immediately breaks down to produce H2L, water, which is liquid, and carbon dioxide gas. So basically I can write down this reaction as sodium bicarbonate reacting with hydrochloric acid to produce sodium chloride plus water in this and carbon dioxide gas. So this is going to be my reaction. Once I am done writing the reaction, I balance it. There is 1 sodium here, 1 sodium, 1 chlorine, 1 chlorine, 1 carbon, 1 carbon, 1 plus 1, 2 hydrogens, 2 hydrogens, 3 oxygens, and here's 1 plus 2, 3 oxygens. So the equation is balanced. Now let's talk about stoichiometry. So that means I can say that 1 mole of, no number means 1 mole of sodium bicarbonate reacts with 1 mole of hydrochloric acid to produce 1 mole of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide. Now how to convert these moles to grams? That means you are calculating the molar mass. So sodium, 1 mole of sodium atom has a mass of 23 grams. I'm taking these numbers from the periodic table. Hydrogen is 1, carbon mass is 12, oxygen is 16, 16 times 3 is 48, and that is equal to 84 grams. That means when I'm taking 1 mole of sodium bicarbonate, basically I'm taking 84 grams. So this 84 grams is the molar mass of sodium bicarbonate. So we normally write it down like this, 84 grams per mole. HCl is also 1 mole. Hydrogen is 1, chlorine 35.5, that makes it 36.5 grams. So per mole. So that means mass of 1 mole of HCl is 36.5 grams. Let's do NaCl. Let's say we are adding HCl into sodium bicarbonate because we want to make NaCl. That means we are mixing sodium bicarbonate and water in 1:1 ratio, and then we'll make 1 mole of this. And 1 mole of sodium chloride means how many grams? Sodium, mass of 1 mole of sodium will be 23 grams. Chlorine is 35.5, which makes it 58.5. So that is grams per mole. So 84, 36.5. So if you are mixing 84 grams of sodium bicarbonate with 36.5 grams of HCl, then you are making 58.5 grams of sodium chloride. This is called theoretical yield. What is theoretical yield? It is the maximum amount of the product that could be formed from the given amounts of reactants. That's the maximum. So, can you make more than 58.5? No. If you are making it, means you are making some mistake. Are you going to make less? Yes, because there are so many experimental errors involved. You are mixing them, the spilling, some other errors, weighing errors, that most of the time when you actually do the reaction, when you actually mix them, then how much you are getting, that we call it as actual yield. This is theoretical, means how much you should get, and actual is how much you are getting by doing the experiment. Amount of the product that actually forms in the lab. Then we calculate percent yield. And what is percent yield? How do you calculate that? You take actual yield, you divide it by theoretical yield, and you multiply that by 100. So let's say you mixed 84 grams of sodium bicarbonate with 36.5 grams of hydrochloric acid, and you did the reaction, you collected sodium chloride, and you took the mass of the product, and let's say you found out the mass of the product by doing the reaction was 40 grams. So that's your actual yield divided by theoretical yield times 100. That will be the percent yield. One last topic that I want to cover here, and remember when I was talking about single replacement reaction and I talked about oxidation reduction reaction, I want to give one example for that. For example, let's look at this reaction. This reaction is not combination, not decomposition, not single or double. It's a combustion reaction. Burning in oxygen is combustion. It is also an oxidation reduction reaction. And the easy way to find is, yes, we said what is oxidation? Oxidation is loss of electrons. But oxidation, you can also define it as gain of oxygen. If something is getting oxidized, that means it is gaining oxygen, or gain of oxygen or loss of hydrogen atom. Similarly, you can also define reduction as opposite loss of oxygen or gain of hydrogen. I don't know why I've started writing in cursive. All right, so let's look at this. CH4 has 4 hydrogen atoms. O2, 0 hydrogen atoms. Carbon dioxide has 2 oxygen atoms. Water has 2 hydrogens and 2 one oxygen atom. So if you look here, I have to compare CH4 with CO2. Why? Because on the left side carbon is in CH4, on the right side carbon is in CO2. What is happening from here to here? Is carbon gaining oxygens or losing oxygens? It is gaining oxygens. There is no oxygen here, but then there are two oxygens here. That means I'm going to say that CH4, which is known as methane, is getting oxidized. If methane is getting oxidized, then this should get reduced. If one is losing electrons, the other one should gain electrons. But let's check if that's what is going on. Go from here to here. No hydrogens, two hydrogens here. That means it is gaining gaining hydrogens. If it is gaining hydrogens, or you can say it like that, there are two oxygens here, and on this side only one oxygen. So it's losing oxygen, and loss of oxygen is reduction. So CH4 is getting oxidized, O2 is getting reduced.